Hello students, so in our previous class we discussed or we started our second module, work and energy, right? In that class we discussed about integral equations of first one-dimensional motion. Okay, so today we're gonna discuss a problem, that is we have to find out the vertical distance covered by a stone when it is throwing vertically upward direction in a uniform gravitational field. So for that we are considering V0 as the initial speed, V0 as the initial speed of the stone. V0 is the initial speed of the stone, and in our previous derivation we considered x-axis as the vertically upward axis, but here we are considering z-axis as the vertically upward axis. And here gravitational force is a constant. Also here we are neglecting air friction, and we know the important equation F is equal to mg. When we are throwing a stone in upward direction, then this equation will be equal to F is equal to minus mg. So in this problem we have to calculate the vertically upward direction or distance covered by the stone. So for that, consider a stone with mass m and its initial velocity v0. So here m is the mass of the stone and v0 is the initial velocity of the stone, and here we are throwing it upward direction, and v1 is the maximum velocity achieved by the stone. So we know that v1 will be equal to 0. When a stone throwing upward direction, then the maximum velocity will be equal to 0. And from our previous derivation, we know the final equation as half mvb square minus half mva square is equal to integral xa to xb f of x dx. This is our final equation of integrating equation for one-dimensional motion. So there will be a small change in this case, that is because we are considering z-axis instead of what, x-axis. So a small change will be there, and this equation can be written as v1 square minus half mv0 square is equal to integral z0 to z1 f of z dz. So instead of vb we are taking v1, va we are taking v0, and instead of x we took z. Okay, so this is the change between these equations. Hope you understood the change. And we know v1 is the maximum velocity achieved by the stone, and this will be equal to 0, which means the whole term will be equal to 0. So this equation will become minus half mv0 square is equal to integral z0 to z1 f of z dz. What is f of z? F of z, that is force, will be equal to minus mg. We already discussed this one. Okay. So the equation will become minus half mv0 square is equal to minus mg. We can take minus m and g outside because both of these terms, these letters were constant, right? Integral z0 to z1 dz. What is integral dz? Which is nothing but z. So minus mg z within the limit z0 to z1. Next, just apply the upper and lower limit. Minus half mv naught square is equal to minus mg upper limit minus lower limit. It is equal to minus mg z1 plus mg z0. We can take this term into LHS, that is mg z1 is equals to mg z0 minus half will be equal to plus half mv0 square. So this z1 is the maximum vertical distance covered by the stone. So we have to calculate the z1. So z1 is equal to mg and mg will cancel each other, that is z0 plus half. M and m will cancel each other, so v0 square divided by g. So this is our final equation, that is the maximum distance, upward distance covered by the stone when it is throwing vertically upward direction in a uniform gravitational field. Okay, hope you understood this small derivation. Thank you.